Hello, everyone. I'm Derek from Apollo, and today I'm going to be talking about the benefits of idiomatic code-first GraphQL development. So, as I mentioned, I work at Apollo, who is a leader in a GraphQL space. I personally work on Apollo Federation, which is our open architecture for building and distributed GraphQL APIs. So, what it allows you to do is you can build a single unified GraphQL APIs that are composed from multiple GraphQL servers. So your clients can interact with single API that then are routed to corresponding GraphQL servers accordingly. If you're building GraphQL APIs or thinking about building GraphQL APIs at any scale, make sure to check out Apollo. So without further ado, let's talk about GraphQL. Right? It is a query language for APIs. Quick refresher, right? It's a runtime that also executes those requests and make sure that you get everything right. But more detail, it's a spec that defines how to expose your data in a certain way such that the clients can selectively ask for the data they want and only for the data they want, right? At the heart of a GraphQL server lies a schema. Schema defines all available data that the clients can access, and then the clients use this information to craft their queries. When server receives this query, well, they're gonna execute the query and return the data that matches exactly the shape of the request. So it's a very powerful mechanism to build a very flexible APIs. And there are tons of implementations out there of GraphQL covering pretty much any major language and framework out there. And when we look at those libraries, they will generally fall into two categories. They're either schema first or code first libraries. And what those mean is basically they describe how you build your GraphQL server. So in a schema first approach, what we do is we first manually create our schema file by hand and then use that as an input to our GraphQL server, where we then add the corresponding resolver logic, so business logic, how to get this data and how to get this data back to the clients. On the other hand, on the code first, what we do is we write code, and the schema is, well, result of this code, right? Seems pretty straightforward. So how does it actually look like in practice? So here is an example using Spring GraphQL, which is a very popular GraphQL library. It's actually a very good GraphQL library. And on the left, we got our very basic schema, just hello world, that takes a name and returns a string, right? On the right, we got implementation there. It's regular Spring Boot stuff. So we get the controller to make it as a bean. And then we have a hello world a function that returns our data, right? And we map it using query mapping to mark it as this is actually our query. It's pretty straightforward, very easy to look at, very easy to reason about. But there's actually a bug in this code, as you probably have guessed. We're going to talk about it in a couple minutes, but just leave it at that. So talking about the schema versus code first, I think that is somewhat problematic. At least in my mind, the naming is somewhat misleading. So first of all, it doesn't really matter whether you write your schema by hand or whether you describe your schema using a code. Schema is your API. That's the client will interact with, right? This is the shape of your data that you want to expose to them. So you want to build the best API for your clients. So you should always develop your GraphQL server with schema first in mind. So in my opinion, a much better categorization of those is SDL first versus code first libraries, right? But technically, any GraphQL library can be a code first library. So code first is also a very broad term. So if we can represent our GraphQL types in a code, and this is an example using GraphQL Java, well, any library can be a code first library. And this was actually the original way to build GraphQL servers when the GraphQL was originally open source. As you may see, this is not the best user experience here, right? It is very verbose, and it's not that I personally wouldn't want to work with the code base like this, but if it works for you, all power to you. So that's why there's some better ways of how we can approach the code first. But when we're talking about code first, this is actually what people might have in mind, right? So we build those low-level GraphQL representation, build the abstract syntax trees, and we got our GraphQL server. So what I want to talk about today is idiomatic code first approach. So what I mean by idiomatic in this sense is that we're going to be relying on our GraphQL library of choice to provide some abstractions around all those low-level nitty-gritty details. So then we can focus on the stuff that matters most. So we write code to return the data, and the library is going to look at this code and, well, generate the schema for us, right? So we can focus just on business logic. That's how we get this data. So since we're going to be writing code to describe our schema, well, let's take a look at a schema and try to identify some characteristics there that would be good to have an idiomatic code first library. So here on the left, you got a very basic abridged version of a Star Wars schema, right? So first thing that you may notice that, well, GraphQL schema is strongly typed. Everything has a type. So having that would be a great thing on our library. Then, if we look at closer at those this schema, right? We have types. They have fields, and fields sometimes have arguments, right? So, in my mind, those kind of map very closely to concepts like you get classes that have properties, and you may have functions returning data, right? The one big feature of GraphQL is that it's null aware, right? So when you define a type for a field, we specify explicitly whether this is a nullable or not nullable field. So those exclamation marks at the end, they tell you that this field is not null. And this is actually a concept that's guaranteed by the GraphQL engine at runtime. So if you describe something as not null, you're guaranteed to get it. If server cannot respond with non-null data, well, that's going to be an error. So some other things that we notice over here, we got some interfaces, right? So the GraphQL supports polymorphism through the interfaces and unions. We return some enum here, so that's pretty straightforward. And we get some extra metadata also in the schema, right? So GraphQL is self-documenting. So in the schema, you can provide descriptions around your types, functions, arguments. So you can see on the top, we are saying that the heroes query return all heroes, right? Very simple use case. But this supports Markdown, so you can have a very elaborate documentation out there. And last but not least, GraphQL also has a mechanism to actually modify the behavior of the schema at runtime, or just provide extra metadata to the user. So here I'm using an example of deprecated, which is one of the built-in directives. And this is going to mark the field as deprecated to the user. So when they try to use it, they may get a warning saying this is actually deprecated and you should use the other query that's available to us. So there's other directives that you can manually create, something like authenticated, or that to ensure that the users accessing the data have the proper permissions, etc. It's a very powerful mechanism to do that. So those will be the characteristics that ideally our idiomatic code first library would support. So today I'm going to be using a GraphQL Kotlin library from Expedia that I actually helped create to visualize some of the examples of how the code will actually look like in the idiomatic code first library that exhibits all those characteristics. So GraphQL Kotlin uses reflections to generate schema from your source code. So you write functions returning data, and that's going to be automatically mapped to a corresponding GraphQL schema. So going back to our example here with the hello world query, example code on the right shows you how you would do it in GraphQL Kotlin. So we create our hello world query class. You can name it whatever, it really doesn't matter. But You implement the marker interface to make sure that this is actually our query. You mark it as a component. That's a Spring thing to mark it as a bean, so it's available in the context. And we got our query. So we got fun hello world that takes a name that is an optional string, and we return a string, right? So there's an implementation out there. And going back to our previous example, using a Spring GraphQL, that was the bug there, right? There was no argument to our hello world query, and yet that still ran perfectly fine. Here, it's described by the code, and it's not possible to do that. If I remove name or argument from a hello world function, it's not going to be shown in our schema anymore. But let's look at some more interesting examples here. So going back to the abridged Star Wars schema, we got our heroes query that takes an enum episode and returns a list of characters, right? This is just a regular code returning data, right? So characters and interface, and we get an implementation down there with a human, right? So this is actually very easy to model, very easy to understand, and this brings me to the first benefit of using the idiomatic code first, which is the developer experience. So in the idiomatic code first approach, you write functions returning data. It's up to you how you want to structure the code there, what sort of data you want to expose, but it's just function returning data. It's very easy to understand, very easy to reason about. It's very easy to onboard new folks to it. And because you have a full control over what you're doing there, if you look at the human class at the bottom, you also control how the data is getting resolved. So by default, a name is a property, right? The property means that I need to compute it before I return anything to the end users. So in order to actually return a human, I need to have a name. But on the other hand, if I need to get a home planet, this can be potentially an expensive call. So what if it takes a second or two to resolve? You don't want to wait those 2 seconds every time someone asks for a name on the character, right? So if you want to resolve this conditionally, what you do is you convert it to a function, expose it as a function. And I'm using here the Kotlin mechanism. The suspend fun is and indicates this is a Kotlin coroutine. So this is the asynchronous mechanism from Kotlin to resolve data. It allows you to write imperative code. So basically the same code as you normally write in a blocking function, but it has a superpower that at certain places in your code, it can suspend its execution waiting for the data. And the coroutine is actually, another coroutine can run in the same time on your thread to, well, do something else. So it's a very powerful mechanism there as well. But as I mentioned, this is just functions returning data, right? So this makes it very easy to test our stuff as well. So you don't need to start a whole GraphQL server to test your resolvers. You can, and definitely you should, create some integration test that verifies that everything works together nicely. But for the most part, you can just write tests that are verifying the individual resolvers and whether they behave correctly or not. But let's look at some other examples here from the code, right? So as I mentioned, GraphQL schema is self-documenting, right? So we can have some extra documentation on our types, fields, arguments, anywhere on the schema elements, right? So ideally, we will want to pull that from the Java docs on the code side, but unfortunately, Java docs are not available at runtime. So what we can do next is, well, we can enhance our model there by using annotations. So we can use the GraphQL description annotation, and we can provide all that documentation there right next to the code as well. On the left, on the schema, I also am using deprecated directive to indicate that this field should not be used anymore to the clients. This is an example how you use directive. And on the Kotlin side, again, we're just using annotations to add that information to the schema. It's right next to the code. So in case of the deprecated, since it's actually a built-in mechanism, and the Kotlin has the same built-in mechanism to indicate features that are deprecated, we can just use the built-in deprecated annotation. If you're building any custom directives, you would still create annotations, and you still would annotate the corresponding elements. So it's still the same behavior. But this is providing some extra metadata, maybe changing the behavior for like the directives. But what about like evolving the schema, right? So what if I want to add a new character query to my GraphQL schema? So it's pretty easy, right? I added there on the left. But what if I forget to add the corresponding resolver, right? So for queries, yeah, it's probably not going to do that. But what if you do that on some extra fields to the character or somewhere else, right? What if you change the return type from one type to another? So an example here is changing character to not null. Well, but maybe you're just changing something else, maybe making a string to int or vice versa, right? This is actually not possible to do and miss that on the code first approach. Since the schema is generated from the code, well, if you didn't write that code, it's not going to be in the schema, right? So the benefit out of this is that we get a single source of truth for a schema. We no longer need to check whether our schema and the resolvers match. We don't need to check the schema for additional information about where our directives are applied or what sort of documentation is there, and then duplicate that in Java docs. We can just look at the code, and, well, everything is there right next to where it's being defined. But Kotlin is also a very powerful language, right? So as I said, we're using it on a JVM. So for our intents and purposes, you can think about as a better, more powerful Java. It's fully interoperable with Java, so you can use all the other libraries there. But in Java, all the objects are nullable by default. So if you define something that returns an object, well, you can just return null, and that's going to be fine, and no complaints there. On the Kotlin side, our contract is actually guaranteed by the compiler. So if I define here as a character, which in Kotlin defaults to not null, and I have to explicitly opt into nullability by appending the question mark at the end. If I try to return a null here, when I say this function doesn't return null, it's not possible to return null, this is a compiler warning. Your IDE is going to scream at you, say, hey, this is broken. You cannot actually build this code. You cannot deploy it anywhere. So GraphQL by itself, if you try to return something that doesn't match your schema, right, GraphQL is going to verify those results for you, right? So if I try to return a nullable value for something that's not null, well, GraphQL is going to catch it for you. It's going to error out. It's going to give a nice error to the users, but this is actually a runtime concern. Using idiomatic code first with Kotlin, you get a build time safety. So before you deploy to production, you can actually catch all those errors ahead of time. But so we get a compile time safety there. That's a huge benefit to productivity and to catch the errors earlier. But what about the schema file? It's actually very useful in the tooling. You can use that, for example, with like some schema registries to capture the like breaking changes, how you're evolving the schema. And there's tons of other tooling that relies on the schema file, right? It's very useful to have that. So the good news is, well, you can still use schema file. It's just the difference is that instead of actually using it as an input to your schema, to your server, you will generate it as a build time, as an artifact of the build. So you have a versioned artifact to deploy, and you have a schema that corresponds to it. And the benefit out of doing that this way is that you are actually getting a complete schema as well. So, for example, you may say, well, what do I mean by that? If you're using something like a relay, right, a lot of the types are generated for you, right? So you don't want to create those extra pagination and cursor and all that stuff. So you generally use some annotations to do that, and the framework is going to generate those extra types for you. If you're using Apollo Federation, right, for the most part, you just apply the directives there, saying, I want to add some extra keys to match my entities. I want to add some extra metadata there, how I want to resolve those things, right? But you wouldn't be providing those directive definitions. You would rely on a framework to add that in to get a complete, full version of a schema. So that's what I mean by the complete schema. So you may start with a schema file that you manually craft, but this is not the schema necessarily. This may not be necessarily the schema that's going to be exposed to your clients. If you generate it at build time, your schema is guaranteed to be the complete schema. This is actually what the clients will interact with and see. So, in a summary, there are tons of benefits of using Idiomatic code-first approach, starting with the great developer experience that makes stuff easy to understand, very easy to reason about, makes it easy to test. We make sure that we get single source of truth. So the code is our source of truth of how the stuff behaves and what is exposed to the users. By using something like Kotlin, we get a compile time safety. So we can eliminate a whole bunch of errors before they get into production. And last but not least, we still get all the benefits of schema, but we get a complete schema with what the clients will see and will interact with. So thanks everyone for my talk, and see you later.